We're going to look at changing the base of a logarithm. Here we can see we've got a logarithm to the base 7. And you might want to change it to another base. Perhaps the most straightforward reason is your calculator might only be able to do calculations with logs to the base 10. Now I know modern calculators are more versatile than that, but in the old days, a calculator would only, if it could do logs at all, would be able to do a log to the base 10. And if you go even further back, you might have only had a set of tables which would perhaps log to the base 10 and the natural log. But anyway, for one reason or another, you may be required to change the base. So I'm just going to pretend for the moment you've got a calculator that can only do log to the base 10, rather than you being asked to sit an exercise and we're just being awkward. And here you might think, oh well, I can use the first law of logs to simplify this. Because if I add two logs, I can just multiply them, the arguments together. No, because the base is different. So again, before we did anything here, we'd need to, if for some reason you did want to simplify it, then you'd need to change the base to so they're the same. So either both are base 4 or both are base 2. Not sure why you'd want to do that in particular, because you're going around the houses a little bit, but this is a learning exercise. You need to remember this. It can be derived, but to be honest, remembering how it's derived is more awkward than just remembering this. Easy for me to remember because in my time I've owned lots of Citroen AXs. I'm well aware what the Citroen BX is. That was the next one up. So for me, I just can key it into my memory because I see these as cars. Log AX equals log BX over and log BA. Just remember that. So we'll look how this works. It's dead easy. You're not going to have any trouble with this. The key thing is, it's obvious that B is always going to be the log that you want to change it to. That's the whole point. So both the top and the bottom have always got to be the log that you're hoping to change it to. Otherwise, there'd be no point in changing it. So, and then we just look, the X is the 120 and the A is the old base. Done. And here we can see, because my old-fashioned calculator has just got the log button, then indeed I can calculate these. So let's do that on my calculator. So I'll do log 120 divided by log 7, and my answer to 2 decimal places is 2.46. Of course, with a modern calculator, you can just check that answer. So I'm typing that in now. And yes, I do get 2.46. Here we've got an equation. This is an equation that you might well encounter. Looks tricky. Log to the base 5. And here we've got a log to the base x, an unknown base. The point is, they are different bases, or potentially different bases. You don't know, what's going on here. So this is how we're going to deal with it. We are going to change them both to a log to the base 5. That makes sense. It's the simplest thing to do. So I'll keep this, but this log x to the 5 is the one I'm going to change. And I'm just going to use this again. I want, again, the top and the bottom, the logs, as I said, have got to be the base to which you're trying to change it to, otherwise there'd just be no point. And this is what we end up with. Now the important thing, this is fine. You could substitute this this back in here. So replace log x to the 5 with this. Now remember, this here is a constant. There's no unknown here, so I can evaluate this. But you might notice that this is saying, what is the index to the base 5 that results in 5? So what is the index to the base 5 that results in the value 5? And we can see on inspection, this is just going to be 1. So we've helped ourselves out a little bit, the simplification there. So now we can rewrite this equation. Now we can proceed. Now, quite a slick technique here is to make a substitution. Set y equal to log to the base 5x. So it becomes y plus 6 over y equals 5. And you're going to solve that. It shouldn't cause you any difficulties. We'll multiply the whole of the left by y and the whole of the right by y. And once again, you will end up with a quadratic with 2 solutions, and you'll set those solutions, which I'm going to give you a hint, y is going to ultimately equal 3. So what we'll have is 3 equals log 5 to the x. And actually I'm going to just do that for you actually. This is going to be one of the solutions. I'll let you do the other. So we're going to have y equals 3. Therefore, 3 equals log 5 to the x. How you solve this, you should be able to solve this if you recognize again what's going on. Here, what I'm saying, what is the index to the base 5 that results in x? So what is the index to the base 5 that results in x? But it's telling me that index to the base 5 that results in x is 3. So I can take this away. And so I can find that x is equal to 125. Okay. I'm just going to do this another way. As I've said before in algebra, there's rarely just one way to do things. This is not a way that was advised, in the standard text, but something that I decided to do. And you be the judge. I'm going to use the third law of logs here and bring this up. Then I'm going to change the base of this as I did before. So I'm going to change it to the base 5. And we're going to use this rule. So we can see that x is going to be here. Going to be there. Okay. So this is just substitution. So this is what we've ended up with. So if I rewrite this equation, make that substitution now. Now you can see here, I can use the third law of logs again to bring this down to the front. And again, you can see here this expression, what is the index to the base 5 that results in 5, is just going to be a value of 1. So I'd put 1 here, but 6 times 1 is just going to be equal to 6. So again, I've arrived at exactly the same equation, just a slightly different path. And again, the trick with this, make your substitution y is equal to log to the base 5x, and then it's y plus 6 over y equals 5. So if I were to make that substitution, again, you'll end up with just the same. And if I was to multiply through by y, I'd get y squared plus 6 equals 5y, and you've got a quadratic that you can then solve. I'm not for 1 minute saying this method is preferable, and it certainly doesn't seem easier, but I'm just basically making the point that as long as you employ the rules correctly, you will be able to arrive at the correct solution, even if it takes a slightly different route. And it shows versatility with you understanding the laws of logarithms. A lot of this, I'm afraid, as always, comes down to experience. It comes down to experience and also always employing the rules correctly.